Hey everyone, welcome back. Today we are dealing with day 19, interfaces. Interfaces are really similar to what we dealt in day 13, which are abstract-based classes. And we can think of interfaces as pretty much the same functionality of an abstract-based class. There's a few minor difference between abstract-based classes and interfaces, but I will mention them later after we complete this question. So for this task, we are given an advanced arithmetic interface on line 1 to line 3, and it has one unimplemented method, divisor sum. So our job for this question is to implement this child class calculator that extends from this interface. And because we extend from this interface, just like an abstract-based class, this interface is enforcing us to implement divisor sum. So our job for this task is to implement this function. So this function is meant to return the sum of all divisors of n. So n, in this case, if n is 25, then all divisors of 25 is 1, 5, and 25. Then we'll just return the sum of all these three numbers, and that is 31. So to solve this question, we can have a simple for loop and define a simple sum accumulator that contains the sum of all divisors of n. So let's get started. This divisor sum will take in an integer and it will return an integer as well. We will define the accumulator sum. This will store the sum of all divisors for n. And to find all divisors for n, what we can do is define a for loop that iterates from 1 to n. And we check whether if n can be divided by this number. And if it is, we would just add it into this accumulator sum. And after the for loop, we would return accumulator sum. So for I in range 1 to n plus 1, we will just check if n percentage I is equals to 0. In other words, the remainder after dividing n by I is equals to 0. In other words, divisible. Then we just do accumulator sum plus equals to I. And we would just return this accumulator sum and we're done. That's pretty much it for this question. And just like that, we have learned how we can make a child class extend from an interface and use that interface to enforce the implementations of methods inside this child class. So the next question that you might ask is, okay, I can see that interfaces behave like abstract-based classes. It is meant to enforce implementations of methods on the child classes. But if that's the case, what's the difference between abstract-based classes and interfaces then? Why are we learning them as two different concepts? The real difference is that interfaces are meant to be used such that all methods defined in the interface are all not implemented. While for abstract-based classes, you can think of interfaces as like a subset of abstract-based classes, where abstract-based classes allow you to have some methods to be implemented and some methods that are abstract. But for interfaces, you can think of it as abstract-based classes under the condition that all methods in this interface are all unimplemented or abstract. So that's pretty much the difference. So you could implement an interface with an abstract-based class, just like we learned in day 13 as well. So let me just give you a simple refresher for how we would do that. So from ABC module, import the abstract-based class child class that we would make our interface extend from. Let's define advanced arithmetic interface, and we just make this extend abstract-based class. So in this case, we have divisor sum, and similarly in this case, we would just put a pass keyword here to tell the Python interpreter that this is not implemented. And let's import this abstract method decorator as well to make it explicit that this function is abstract, in other words, not implemented. And just like that, what we could have done is this is pretty much an abstract-based class that's really behaving like an interface. To be specific, every single method inside this abstract-based class is abstract, so you can take it as an interface. So we could make calculator extend from here. But just for information, like if you run this code, it would fail because HackerRank wants us to use the interface defined on line 1. So yeah, that's pretty much it. Like hopefully this makes it clear for you what interfaces are. Frankly, for me, in my experience as a software engineer using Python for the past few years, I personally don't really find the concept difference between abstract-based classes and interfaces useful. But the concept for what an abstract-based class or an interface is used for, like it being used to enforce methods to be implemented on child classes, those are often used in production. So in summary, Day 19 is pretty useful for your learning. So with that, that's pretty much it for this demonstration. I hope you liked it. If you have any comments, please leave them in the comments, and we will see you in the next video.